Hi guys, in this video what we're going to do is going to look at what's called the limits of sequences, and I just want you to consider a limit whose formula is given by un is equal to n over n plus 1, and what's happening here is we've put a few numbers in. So we put 1 in, we get 1 over 1 plus 1, which is a half. We put 2 in, we get 2 over 2 plus 1, which is 2/3, 3 over 3 plus 1, which is 3/4, and so on and so forth. Now hopefully what you'll notice is that a half, you can see here, 2/3 is greater than a half, 3/4 is greater than 2/3, 4/5 is greater than 3/4, and so on and so on and so forth. So if we keep going with this sequence, it's going to tend towards a certain value, because you can see that this here, half, 2/3, 3/4, 4/5, 5/6. If I go to a really big number, if I choose n is equal to 1,000, that's not even a big number, 1,000, then my actual fraction will be 1,000 over 1,001. Now hopefully you can see that this is very close to a certain number. It doesn't quite get there, but it's very close. If you stick that into your calculator, and I keep going bigger and bigger, it's going to tend towards 1. So we're going to get very close to 1. So as n heads off to be a really big number, infinity, what we're saying is that this particular sequence is going to tend towards 1. So what we can say then, as the limit, because that's what we say, it's never actually going to reach there. Okay, it'll never actually get to 1. It'll get very close, but it'll never actually reach 1. That's what we call a limit. Okay, so as the limit, as n heads off to infinity here, of this particular formula, then it's going to equal 1. So this is what we're saying is, as the limit of n heads off to infinity of n plus 1 is equal to 1. Now, sometimes we can see these by inspection, by just putting some big numbers in. And it's also sometimes, well, it is important to recognise that not all sequences have limits. So 1, 4, 9, 16, all that's happening here, you can see these are the square numbers. So as we keep going, so if we keep going, 5 squared would be 25, and so on and so forth. As we get to a big number squared, for example, 1,000,000 squared, you can see that's heading off towards positive infinity. It's not going to converge on a particular value like this one did. It's going to diverge, that's what it's called, divergence, and it's going to diverge to positive infinity. So it's going to keep going to positive infinity. Okay, so let's have a look here. It says a sequence is given by un is equal to 2n over 2n plus 1. Write out the first 4 terms of the sequence. So the first thing we do, we just write a few things out. So we've got u1 is equal to, and we've got 2 to the 1 over 2 to the 1 plus 1, which is 2 squared plus 1. In that case, that's 2 over 5. We've got u2, is equal to 2 squared over 2 cubed plus 1, which is equal to, 2 squared is 4, 4 over 2 cubed is 8, so we've got 4/9. The next one is u3 is equal to 2 cubed over 2 to the 4 plus 1, which is equal to 8, and that's over 16 plus 1, which is 17. u4 is equal to 2 to the power of 4 over 2 to the power of 5 plus 1, which is equal to, in this particular one, is 16 over 33. Okay, so where is this heading? It says find by inspection the limit of this particular sequence as n heads off to infinity. In order to do this, it's actually easier to write these as fractions, decimals, sorry, not fractions. So let's have a look. 2/5 is 0.4. 4/9 is 0.4 recurring, so 4. I'll just put a dot there to show it's recurring. 8 over 17 is 0.470588, and the last one there is 0.484848, etc. So that there will keep going forever. Now hopefully you can see roughly where this is trying to head towards. You can see it's started at 0.4, it's heading to 0.5, you can see. So I don't think the limit will go past 0.5, because you can see here it's getting closer and closer to 0.5. So the lim of this, you can remember the lim as n heads off to infinity of 2 to the n over 2 to the n plus 1 is equal to a half, or 0.5. Okay, here what we have are all the special limit laws, and this is just allowing us to move around our limits and doing stuff. So you can see here that what you need to do is just need to be aware of this, that when we're sort of looking at all the algebra that we need to do and we want to change things, we can do all of this. Now, the most important thing that we're going to use on this course is that what we are trying to do, if we're trying to evaluate the limit of a fraction, so to evaluate the limit of a fraction, what we're going to do on this course is we need to divide everything by the dominant term. Okay, by the dominant term. And I'll explain what that means in the next slide. So that there is the main thing that you need to be taking away from this. Yes, some of this is important, and if you read this, it will make sense. But to evaluate the limit of a fraction, we're going to divide everything by the dominant term. So let's have a look here. You can see I've written that again on this slide. So what does that mean? Well, essentially what it means is we're looking for the greatest power, the greatest index. I'm going to divide everything by that index. Okay, so that's the important thing in this particular technique. So if I have a look at I, what we have here is we have the lim as n heads off to infinity of 3n minus 1 over 2n plus 3. Okay, and I'm looking for the highest power of n. And the highest power of n here is just n. So I'm going to divide everything by n. So what I'm going to end up with now, the next one is lim as n heads off to infinity. I'm going to get 3n minus 1, just going to leave a little bit of space here, over 2n plus 3. And what I'm going to do is going to divide everything by n, like that. And I'm going to go through each term and just rewrite it again. So lim as n heads off to infinity. And what we have, look at the first one, 3n over n, so that's just 3. Okay, so 3. Minus, well, 1 over n, I can't do anything with that, so I'm just going to leave it as 1 over n. I've got 2n over n here. So again, the n's will factor out and I get 2 plus, and notice for this one here, again, I can't do anything with that, so it's just 3 over n. Now, I'm now going to do the limits, which means that I'm going to set n heading off to infinity. And you can see here that there's no n's here and there's no n's here. So these two things are not going to be affected, but these things are here. And you can see here that 1 over n. Now, as n gets very, very big, I want you to think of this in terms of a pizza. And what I have is I have one pizza between two people, which means I get half a pizza each. That's pretty straightforward. But suppose that I had 1 million people and I'm trying to feed that pizza, that one pizza to 1 million people. It's quite obvious that we're not going to get much pizza. In fact, we're going to get pretty much nothing, because as n gets larger here, as we try and share that pizza between more and more people, we get less and less of a slice. So eventually what's going to happen is it's going to tend to 0. It's going to go, we're going to get pretty much no pizza. We'll get a tiny little bit, but it might as well be nothing, which means that this is going to become equal to 0, and this is also going to be equal to 0. It's the same idea. It doesn't matter if it's one pizza between 1 million or 3 pizzas between 1 million. You're still, as the number gets really, really big, you're still going to get no pizza. Okay, so that means that once we take the limit, it now becomes 3 minus 0 over 2 plus 0. So that means we're going to get 3 over 2 is what it's going to go towards. That's what the limit's going to go to. Let's have a look at II. Same sort of idea. I'll leave a little bit more space on the top one this time. So Ln heads off to infinity, the limit. We've got n cubed plus 3n minus 1. Leave a little bit of gap, I'm going to do some division there. 2n squared plus 3. Okay, so again I look to see what is my biggest power. But I've got a cube here, and that's the biggest power, so I'm going to divide everything by a cube. Okay, so again, this in blue, we've got over n cubed, over n cubed, over n cubed, yeah, over n cubed, and over n cubed. Notice I'm just dividing everything divided by n cubed there. Tidy it up, so I've still got the lim. As n heads off to infinity, I've not taken the limit yet, so it needs to be. You need to keep that in your workings, because you need to let the person know that you've not taken the limit yet. And you can see the first one is n cubed over n cubed. That's there just equal to 1. Plus 3n cubed, 3n over n cubed, sorry, that is 3 over n squared. And the last one is just minus 1 over n cubed. There's nothing we can do about that. divided by n squared divided by n cubed is just over n, so we've got 2 over n for this one. Okay, plus 3 over n cubed over there. Okay, so same sort of idea. Because we are now dividing by n, we're happy that that's going to, when we take the limit, that there is 2 pizzas and it's going to be divided by n people. But if you look at this one here, we have the n squared. That just means that it's getting bigger quicker. So these 3 pizzas are, the ends are just getting quicker and quicker and quicker. They're becoming bigger and bigger because of the square and the cube here and the cube here. So all that's going to happen is this is going to tend towards 0. This one here, here, and here are going to tend towards 0 quicker than this one here. So all that's going to happen here is we're going to end up with 1. We're now going to take the limit, so that we need to drop the limit notation. So 1 plus, and this here is going to be 0, because 3 divided by n squared, as n gets very big, then you're going to get no pizza, to use my analogy. So that's 0 minus 0, same idea with this one here. Again, because this is going to get big quickly, that means that you're going to get no pizza. Next one is 2 over n, we already know that that's 0, okay, plus, and we've got 0 here, which means we end up with 1 over 0, which means that there is no limit, i.e. it doesn't exist, so limit does not exist. And the reason it doesn't exist, guys, is because we've got a division by 0, and of course in maths we know that we can't divide by 0, we're not allowed to, so if we end up with a division by 0, it means that the limit does not exist. Okay, let's have a look at the last one. So again, I'm going to write the limit as n heads off to infinity. I'm going to leave myself a bit of room again. So we've got 5 by 3 to the n plus 4.2 to the n. Okay, we're going to do some divisions. Going to leave a nice bit of space for us there. And we've got 2.3 to the n, and we have plus 1. Okay, so what's the biggest thing here? Is 2 to the n the bigger? We're going to get quicker, going to get larger quicker, or 3 to n. Now these are exponential functions, so if you think about it, as n increases here, so I get 3 to the power 1 is 3, 2 to the power 1 is 2, 3 squared is, or 3 to the power 2 is 9, 2 squared is 4. So hopefully you can see that 3 to the n is getting bigger quicker than 2 to the n, and that's the one we want to pick because we want the one that's getting bigger quicker. Just like we did here, we divide by n cubed because n cubed is getting bigger quicker than n squared, which means that we can use the idea that the limit as the larger, or as n is on the bottom, will go to 0. So we're going to divide everything by 3 to the n here, so we'll end up with 3 to the n, 3 to the n here, 3 to the n here, and 3 to the n there. And we're just going to rewrite. If we rewrite, we get the limit as n heads off to infinity again. And what we end up here is 3 over n over 3 over n. Here, hopefully you can see it cancels. So, or factors I should say, is 5 plus, and what we have here is, you can see that nothing will cancel there, so we just end up with 4 to the 2n over 3 to the power of n. Okay, all over the one on the left here again, 3 to the n over 3 to the n will factor out and leave you with 2. So that's just 2 plus, and again 1 over 3 to the n is what's left here. Now this is an interesting one, a bit more interesting than what we had before. So the 5 and the 2, when we take the limit, they aren't going to be affected because there's no n's in there, so they're fine. But hopefully you can see here, we just had that discussion that 2 to the n is going to increase slower than 3 to the n. So as n gets very, very large, this still will be bigger than this. And it's going to get bigger and bigger and bigger. And as n gets really, really big, the same sort of idea is going to happen, guys, where this is going to get bigger quicker than this, which means that as the limit, as n gets very, very, very big, the limit then will become 0 again, as the same sort of idea as this. Again, same idea, 1 pizza between 3 to the power of n. If you start putting n is equal to 1 in here, you get 1 over 3. If you put n is equal to the power of 100, 3 to the power of 100 is a very, very big number, and therefore you can see here we're going to get nothing. This is going to take a little bit longer to get towards 0, but as I said, as n heads towards infinity, which is an incomprehensibly large number, then this will beat this one dramatically, which will send this to 0. So we're going to take the limits. Remember, we can now drop the limit notation, which means we end up with 5 plus 0 over 2 plus 0. So the limit for this one is 5/2. Right, hopefully that makes some sense, boys. Okay, the last sort of example you might be asked to do, this is a nice one. It's used a nice little trick here. So you can see here it says evaluate the limit of n heading off to infinity of n plus 2 over the square root of 2n squared plus 1. And what we're going to do here is we're going to try and get everything in terms of one square root, which will make our life a little bit easier. Okay, so you can see here at the moment, so I'm just going to go through this nice and slow. We've got lim as n heads off to infinity. And we've got this n plus 2 over the idea of 2n squared plus 1. Now what I want is I want something of the form where I can take the limit outside. So this is what I want, as n heads off to infinity. And I want a big square root where I can do all my work in that square root. So in order to do that, what I'm going to do is I'm going to use a little trick where I'm going to say I'm going to square this, and I'm going to take the square root of that. That means I have the square root on both top and bottom, which now means I can combine those square roots. So that's still the same. I've not changed it because n plus 2, and if I square it and I square root it, the square and square root cancel and leave with n plus 2. But it now means I have it with the form square root over a square root, which means I can combine those two square roots for the next stage. So that now means I have this. I now have lim as n heads off to infinity of this big square root of n plus 2 all squared over 2n squared plus 1. Now the only other thing I can do here is, remember, we were trying to find the largest power to divide by. So what I'm going to do is I'm going to multiply out the brackets on the top there, so the bracket I should say, and we're going to end up with lim as n heads off to infinity. Don't forget to leave the limit in, guys. You've not taken the limit. It needs to stay there until you actually take the limit. So let's multiply out that bracket. So if we multiply out that bracket, we end up with n squared plus 4n plus 4 all over 2n squared plus 1. Now what we can do next is we can take this limit here, and using one of the laws that we had on the slide previously, we can put it inside of here. That's absolutely fine. Doesn't matter if we have it outside or inside. So what I now have is a big square root here, not a very good one, but the lim as n heads off to infinity of n squared plus 4n plus 4, is going to extend that out, all over 2n squared plus 1. And now we're going to divide by the highest power, which is n squared, so it's going to be quite a big one now. So let's just draw it. So we've got, yeah, that'll do. So I now have the lim as n heads off to infinity of n squared. I'm going to just rewrite it and then do the division in a second, plus 4n plus 4 all over 2n squared plus 1. And I'm going to divide everything by n squared, so n squared, n squared, n squared, n squared, and n squared here. And I'm just going to move up here and rewrite it again. So we've got another big square root here. Lim as n heads off to infinity. Notice I still haven't taken that limit. And I get n squared over n squared, which is 1. 4n over n squared, which is 4 over n. And then we have 4 over n squared, which is fine. All over 2n squared over n squared, which is 2. And then what we end up with is plus 1 over n squared. Now I'm going to take the limit. So if I take the limit, this will go to 0. I think we should be happy with that on the previous slides. Now this is going to be 0 and this is going to be 0. So which means I'm going to be left with the square root of 1 plus 0 plus 0 all over 2 plus 0, which is the square root of 1 over 2, which is exactly the same. As you probably get away with leaving it like that, but mathematically we should write the square root of 1 over the square root of 2, which then is 1 over root 2, and we are done.